All right, how's everyone doing?
What's
Can
up?
everyone? Hey, what's up? Everyone can hear me okay?
Yeah.
Everyone can access the
Yeah.
chat and stuff. People can join, so that's good. Fix that.
It's it.
All right, let me open this up. I don't really have like detailed slides, just mostly to remind me what the heck we're talking about.
It's probably good.
Yeah, it's probably a good idea.
So the game plan is you're showing us kind of like some basic stuff on Unity, kind of like a Unity Hello World kind of tutorial, or
Yeah, that's pretty much it. It's going to go through a few of the basics. We're going to start with where to download it because they have a hub that you can download that's useful. We'll go over the interface of Unity, and then we'll go over some basic concepts like game objects, how to use colliders in physics, how to get user input, and then what a prefab is. You know,
awesome. I'm
exciting
psyched.
stuff
Woo!
like that. Yeah. There we go. We got some excitement in here. I like it.
We got one.
We got one.
Yeah.
So it's 5:02. I could start now. We have what, 8 people, so I guess I'll post a reminder to people in the chat. That'll just absolutely make everyone angry by pinging them, as I like to do. All right.
Guerrilla marketing.
It really is, yeah. Okay, I'm gonna get started with how to install it. It's pretty easy, but you know, it's just, you might as well go over it. So I have the download page here. So yeah, what I would recommend when you download Unity, there's a few versions you can get. The basic version is free. And you pretty much download everything. Oh, that just gives me it right there. Okay, well, if you go to this page and you click download Unity Hub, then it will download the hub. The hub basically just has all your Unity versions. So this is what it looks like. It has the list of all your current projects that you can just open. It has some tutorials, and it has some blogs and such. And then it shows you what all your installs are. So when you install Unity, normally you'll choose you'll either just install the hub, and then you can go here and add a version. So I would just grab the most recent active version. Or when you install it, you might choose your Unity, which will, I think, give you the hub as well as one install, just like the default install. So that's how you do that. The hub is just used for launching projects. It's not actually Unity itself. So let's get into the Unity interface, because that's what we're here for. I'm going to make a new project, and I'm just going to make it 2D because we're going simple here. So I'll create that. You can make if you notice there was a few different options, 2D, 3D, and then a bunch of other 3D options like 3D universal render pipeline and all this other stuff. Those are basically just presets to use different render pipelines, which is like for lighting and graphics if you want to do more advanced stuff like that. Generally speaking, you just either pick 2D or 3D depending on your project, unless you're doing some more advanced graphical stuff. So yeah, we'll get this just basically making a new project. And then we'll get into the interface. How many of you guys already have Unity downloaded versus how many of you guys don't even know what Unity is? What's the levels of experience here?
I know of it, I haven't used it.
Okay. Yeah, it can be used for a few different things. You mainly use it for game development, but you can use it for any kind of VR application. You can use it for a bunch of different things. Some people actually use it just for like rendering. Don't have it. Never used it. Nice. Made a couple games before. Nice. You have it. Okay. Nice. So we got it. We got a variety of different backgrounds here. Okay. So let's go over the basics of this interface. When you open up Unity, it'll look something like this. In the middle of your screen, we got some water here. Sorry about that. In the middle of your screen, oh man, sorry, one sec. It's scuffed, I'm sorry. Okay, in the middle of your screen, you'll see the scene view. And the scene view is where you'll typically be putting together what the player sees. So that's where you're actually gonna be building your game, seeing the objects in your game, and otherwise editing things. On the left here, you'll have the hierarchy, and the hierarchy shows you a list of all of the objects in your scene. So in the default scene here, we just have a camera. So a camera is an object that determines what is displayed to the player. So if I look at my camera object here, by default, it's created this box, which is showing me that's the box that the player is going to see on their screen. So that's that. And you can see here on the right now, when I clicked on main camera, we have a bunch of information here. This is called the inspector view. And this is where you're going to look at all the properties and all the details of your assets and game objects in your scene that you're using. And I'll go over what these different words mean later, like game object. But for now, we're just going to look at what the windows are and what they generally do. The project window at the bottom here is where you have your assets. So for example, scenes, you might have art, like 2D images. You might have scripts in here. It's basically assets is anything that you make for your game. So textures, scripts, assets, all this sort of, all these files that are being put into your game. And finally, we got the console. And the console is really, really nice for seeing what goes wrong in your game, which is going to happen a lot when you're developing. It's also great if you're wanting to debug a program, if you're doing programming, the programming side of Unity, or of game development in general. It's very helpful sometimes to print out, values and see what is actually going on behind the scenes. And when you print stuff, this is where it's going to go. So this is also where you'll find errors about things that are happening in your game when you run it. And the last window I'm going to go over, obviously there's a lot of different windows here. And if you drop down the Windows menu, you can actually see there's a lot of different windows you can open up. And those are generally for more specific things. The last general window I'm going to go over is the game view. The game view is like the scene view, but it only renders the things that your player is actually seeing. The game view is basically a preview of what your program is. And interestingly, you'll notice that, remember in the scene view, we had this border around the camera object. That border is actually this border on the game view. So this is showing you what the camera is seeing in your scene. Okay, so any questions about the interface? If not, we'll move on.
Hey, sorry.
Yeah.
So when sorry, I should have been paying attention.
All good.
When I create a new project, is like the one that you're doing, is that 2D? Or because when I made a 2D one, I didn't get the same screen as you. Oh, same with 3D.
Right. So you're talking about when you open up the Unity hub.
Yeah.
So are you seeing this window right here with the?
Yep.
And you picked 2D and you created a new project? You said create?
Yeah.
And then it brought you here and this looks different, right?
Yeah. I don't have animator and animation up on there. Or did you add those?
Oh yeah, those are ones I added. I think like.
Oh, okay. So that's
stores,
like in a plugin store or something.
Exactly. Yeah, it stores it across all my projects. So
okay,
when I made a new project,
right.
yeah, no, you're good. And
okay.
And also
Got you.
like sometimes if you already have a Unity install, like an older install, they've had different layouts in the past, default layouts. If you go to the top right, you'll
Yeah.
see all like the default layouts. So I think
Okay.
this is just default. But
Okay. Yeah, I was just wondering about that. So I think I'm on the same page as you then. Thanks.
yeah, it should be good. Yeah, you'll notice I have like tile palette open and project settings and animators. But yeah, don't worry about those. We won't be going
Okay.
over those today.
Cool. Yep. Thanks.
Okay, so now let's talk about game objects. Game objects are basically anything that we're going to be using in our scene. So this is any object in the game. That could be the camera object itself, which is rendering the part of the scene that we want. It could be a square in our scene, just a random square. It could just be an empty game object that's just running a script. Maybe every 5 seconds it prints something to the console and it's just invisible in the world. But anything that actually has logic in our game is going to be a game object. So for example, if we right click here in the hierarchy, we can see we have a list of different things we might want to create. So we can create an empty game object, and an empty game object is just a transform. So a transform just determines its position in the world. Right now we're using a 2D view, so we can kind of just ignore the third column there. But this transform, this game object doesn't have any art on it. It doesn't have any logic. It's just there in the world. So I mean, we can move it around, and you see this little icon in the middle moving. That's just a representation of where it is, so you can actually see it in the scene. If we go to our game view, there's nothing there. So that's an empty game object. That's not very exciting. Game objects on their own don't really do anything. They just sit in the scene. What's interesting about game objects is when you add components. Components are what we use to store values and behaviors for the game objects in our scene. So let's say we go down to 2D objects and we create a sprite. A sprite is basically a term that means like a flat image, like just an image basically. It's like a 2D image in essence.
Yeah, so like Mario would have several sprites to show Mario running, for example. You'd have like one with his foot up a little bit, and then his foot up a little bit more, and then his foot up a little bit more, and each of those would be one sprite. Is that correct?
Yeah, so
Yeah, okay.
yeah, a sprite is just one image. If you have, each of those is one sprite. And yeah, animations are generally a series of sprites. You can, like, a sprite is something like a PNG or a JPEG. It's nothing out of the ordinary. So now we've created a new sprite here. And the difference is that on the right, we can see it has something called a sprite renderer. Now, we don't have a sprite right now, but we can see it's given us all sorts of properties that we can use to modify this thing. So I'm going to open up our handy dandy program called Paint. You might have heard of it. It's pretty cool. And I'm going to make a blank sprite that is, this is like a hidden mini tutorial within the bigger one. I'm going to make a 100 by 100 white square. And I'm going to save this into our project, which I believe is example project. Under assets, and I'm going to make a new folder, and I'm going to call it sprites. And in here, I'm going to save it as square. So now, if we go back to our scene, so I went through that kind of quick. Sorry if that was really quick. When I opened up the example project, I went to the assets folder, and the assets folder is the same folder we see here in our scene. So when you put something in the file explorer into the assets folder, like the sprites folder I made, you can see it now showed up in our scene. And if we open this up, we can actually see that square image we just created. In the same way, I could have created that sprite anywhere on my computer and then dragged it into this interface, and that would have done the same thing. So now I have this square, and we can see that it's just a square, like we created it. It has all these properties on the side. Anytime you have an asset, Unity creates a meta file. It's, if you go in here, you can see square.png.meta. That's like, okay, what is that? And that just stores all the information that Unity is going to use to configure that thing that you imported. So in this case, it's given us a bunch of options like pixels per unit and sprite mode, extrude edges, a bunch of stuff that is like, what is this? You can pretty much ignore most of these things for any kind of project, like beginner to intermediate. Most of this stuff isn't going to come into play. yeah, the only thing I would say for sprites is pixels per unit, but we can go over that later. So now we have our new sprite, and we want to add it to our game object here. I'm actually going to call this the player. So you just rename an object here at the top. So now we have our sprite renderer, but we don't have any sprite in it. It's just, it's just that little empty square here. If I drag it up, it's just this little empty thing. So now if we take our sprite that we dragged into the scene that we made in Paint, and we go to the player, we can assign this sprite to the game object just by dragging it right into the sprite field here. And right away, we can see that now in our scene, we can see that 100 by 100 square.
Yeah.
Yeah,
That's awesome.
exactly. That's what I'm talking about.
Now we're getting somewhere.
Yeah, now it's interesting, right?
Yeah.
Okay.
Awesome.
So now we've got this 100 by 100 square, and that's all cool. And if we actually run our scene by pressing play, it's going to be a square. And, that's exciting and all, but what if we want some movement? What if we want some action? You know what I mean? So now that we have that, let's move on to physics. Physics is where things get interesting. Unity has a built-in physics engine for 2D and 3D games. So this is one of the things that Unity provides that makes it really awesome for game development, is that all the physics is built in for you. All you have to do is just add a component to an object and things just work. So let's look at that process. So we see our player object that we made here. And so far it just has a transform, which determines its position in the world, and a sprite renderer. The sprite renderer just makes it look like whatever we want. So now we want to actually make it have physics. To make something have physics, you're going to add a component called a rigid body. So a rigid body is basically saying, hey, I have physics now. It gives the object mass, and it gives the object different basic physics properties that will make it interact through the physics system. In this case, we're going to choose rigid body 2D since we're using a 2D game. And again, this gives us a bunch of properties. And this is kind of like learning any new program. You have to be able to separate what is advanced, or like what is kind of unnecessary information that the UI is giving you, from like what you actually need to change. You'll notice when we use the sprite renderer, it gives us all these fields, but if we want to display a square, all we had to do was drag the sprite right into this first sprite dropdown, and we can kind of just ignore the rest for now. It's kind of the same thing with the rigid body. We've got all this information here, but for now, all we're going to look at is the body type. There's 3 types of body types, and we're just going to look at 2 for today. We're going to look at dynamic, and we're going to look at static. A dynamic game object means anything that moves, so it's dynamic in the scene. A static game object means anything that doesn't move, so it's not changing in the scene. Pretty much the only difference between those is that a static game object might be something like a platform, for example, or the ground. It's not going to be affected by gravity. Your player's not going to be able to push it. It basically represents just a solid, non-moving object, but it can still interact with other objects. Dynamic is anything like a player that's moving, an enemy, or like a projectile that the player's shooting. So because this is our player, we're going to make it dynamic.
Sorry,
Sorry
to interrupt. So dynamic would be a player or an enemy or whatever, something that moves. What's kinematic again?
We didn't go over kinematic right now. That's,
okay. Sorry, that's for another one. Okay.
Yeah. All good. No, thanks for asking. Sorry, I didn't notice. Parsa said, where is the recording going to be? I'll post the recording in the Discord server after we finish this. And yeah, I guess I have Zoom recording. I think I haven't used Zoom recording before. I'm gonna assume it works properly. It says it's recording, so yeah, hopefully that works. Yeah, sure. I'll post the Discord link for anyone in the chat who came from one of our other platforms. We use our Discord for pretty much all of our coordination within the club. It's all of our announcements as well as our activities and chats and project work. So there's the Discord link. Okay, so back to physics, because physics is fun. Yeah, no problem. Gonna get my tabs open again here. Okay, so we have our player object, and we've made it dynamic. So now this thing has physics, and it's going to be able to move. So now if we play the scene here, whoa, our sprite just fell, right? So that was kind of exciting. Since we made it dynamic, it's able to be affected by physics. And by default in Unity, when you make a 2D game, they've already set up basic physics for you. So our scene has gravity downwards on the Y direction. So everything falls downwards if it's dynamic by default. So that's kind of fun. So, but now we want to make the object not just kind of fall endlessly into the void, because that's just not going to be a very, very fun game. So I'm going to make another sprite, and I'm going to call this ground. And our ground is going to just sit here. It's going to be a platform, and our goal is that we want the player to just land on that and not fall out of the scene. So I'm going to give it the same sprite that we used before. It's going to be this one. This time I'm going to use a new field called color. You might be able to guess what this field does. I know this is advanced, but it actually changes the color. So I'm going to make this a nice puke orange, just for, you know, why not? And I'm going to add a rigid body again. So now we have two components here. One of them is our ground, and one of them is our player. So I did the exact same process that I did for the player here, but I'm just changing two things. I changed the color of the sprite, and I'm going to change the body type to static so that it doesn't fall. You can see when we do that, a lot of properties go away because it's no longer involved in any kind of forces or anything like that. So now that we've made those two changes, we can start the scene, start the game, and we can see, oh, it fell through. Like that's why'd that happen? Like
Collision detection not engaged.
Yes, collision detection has not yet been engaged. We have physics objects, but they don't understand anything else in the scene. They just they obey gravity, they obey basic physics rules, but we haven't actually said that these two objects have bounds or like that they can actually collide against anything. So we're getting closer, and I'm actually going to scale up this platform a bit more on the x-axis, so it's more of a platform. It's changing the x scale in the transform. And now we're going to introduce a new component, which is also a useful physics component, called a collider. And guess what? It makes it collide against things. You can see we have a lot of options for colliders here. In our case, we're going to use a box collider. And since it's 2D, it's going to be box collider 2D. And there's really not anything we have to do to get this to work. By default, when you add a collider, it'll map the edges of your collider to the edges of your sprite. So if you have a very complex sprite, sometimes you might need to modify that, and you can do that by pressing Edit Collider. But since we just have a square, yeah, it's just going to be a square.
Game engine makes things so much faster than if you're building things from scratch. Oh my gosh! Wow.
Yeah, yeah, I know it's pretty crazy. If you're in first year and you're taking computer science 1, 2, 3, you might learn about processing, and processing is a really awesome language that has a nice interface for doing a lot of cool graphical stuff, and you can actually make games in that. And it's pretty cool for making games. You can make graphics programmatically really easily. So I highly recommend that course, Computer Science 123. But once you've learned that and you come to Unity, you'll start to see a lot of the things you had to deal with manually, and that, like creating your own physics and everything, become a lot easier when you can just slap a component onto an object.
Yeah, I use 3JS for doing like JavaScript web animations. And yeah, I was going to build a game in that. I think I'm just going to use Unity. So
Yeah.
You convinced me. Good job.
All right, step 1 done. And yeah, you can, and yeah, to go further on that, as a side note, you can export Unity to most any platform, including web projects. So that's pretty nice.
Yeah, this is awesome.
All right, so now we've added our collider to the player object. By default, all these settings are going to be what we want. Now we're going to go to the ground object, and we're going to add a box collider 2D to that. And yeah, there's really not much we have to change here. By default, these are just big squares or rectangles in this case. And our collider is just going to apply all of those bounds and restrictions needed for these two things to collide. So now let's try it and see if this works. Boom. So that was pretty cool. Or at least it was cool to be.
Mic
Because
drop.
Okay, wait. Gustavo says, any comment about construct? I'm not sure what you mean. I'm sorry. Is that a different game engine? I'm probably not certified to. It's also a game engine. Okay. I haven't used it, so it would be hard for me to make any points of comparison. When I was in high school, I used an engine called Zero Game Engine. If you come from, if you studied here locally in Kelowna when you went to high school, you might have used Zero as well. And yeah, Construct is pretty good for 2D games. Okay, cool. There you go. Parsa, how do I join the club? So we have a Discord link that I posted above, and if you click on that Discord link and join the server, you've pretty much already joined the club. That's where all of our activity goes through. The last step, if you want to be part of our mailing list, in the welcome channel of our Discord, yeah, I can resend the link here. In the welcome channel of our Discord, you can also find the link to our mailing list and the rest of our platforms, so our social medias and email address. Yeah. Anyone who wants to join, club's open. It's free to everyone. So hopefully we can see you there. And we have, I'll talk about it more at the end of this, but we have some beginner and intermediate level challenges that we're running every week that you'll have people to help you with and work with on those if you're interested to start getting into making games and start meeting other people in the community. So I'll talk more on that in the end, but that is one thing we offer. All right, so now that we have this collision, this is awesome. And this is pretty much like, this is like these tools alone that I just introduced here with Rigidbodies and Colliders can already give you quite a bit of potential when you're making a game. So, for example, one of the first projects I did in high school, there was no coding, there was no nothing. It wasn't made in Unity, it was made in a similar game engine. The entire thing was just your player, you have a player, and it just starts at a certain spot, and using gravity alone, it just rolls through a bunch of things. I think it's called a Rube Goldberg machine. So you can actually almost make like a simulation just using the graphics that Unity gives you. So that's already pretty interesting. But let's go a bit further and see what we can do with code. So the next thing I want to talk about is user input. User input is obviously pretty important when you want to have an interactive experience. Things like movement, shooting, using a UI, like a main menu, for example. All of these things require user input, whether it's the mouse or the keyboard or a joystick, whatever else you have. So let's look at how we can actually take user input and make it do something interesting in our scene. All right, so the first step I'm going to do is I'm going to make a scripts folder, because now that we're doing some logic for our player, we're going to need to make a script. And don't be overwhelmed by this. Oh wait, no, not that. I need to make a folder. Don't be overwhelmed by this. If you're, I mean, I guess like if you're taking a Java course right now, if you're taking like Computer Science 111, for example, this is going to be very similar to the things you're going to learn in that course. So object-oriented programming, and basically just the basics of variables and methods is going to get you through a lot of scripting you might want to do in Unity.
What's a variable? No, I'm just playing.
All right, sounds good, Clement. Maybe we'll see you around the club later on. All right, so we've created our scripts folder, and I'm now going to create a actual script, which I did initially and meant to make a folder. But yeah, so the first thing here, C# script. So C# is the language. I'm going to call this script player, because that's going to control the logic of our player. So in Unity, I should explain what a script is. I mean, a script, you know, it might sound intimidating. It's, you know, oh man, we're going to programming. A script in Unity is actually a component. So for example, a Rigidbody 2D is a script. And so when we make new scripts in Unity, we're basically just programming a basic component that'll do some logic for us every frame or when certain events happen. So I'm going to, now that I've created this script here in the scripts folder, if we go to add component, you can actually search up player, and our player is here. So it automatically looks in the assets folder for any scripts you might have, and it'll add them to the list of possible components that you can use.
Can I ask a quick question?
Of course.
Okay. Can I use JavaScript? I thought you could use JavaScript for Unity. Just curious.
Yeah, you can use something called Unity script, which is like a
JavaScript superscript.
Yeah, exactly. It's like a varied JavaScript. I haven't used that personally, but if
Okay.
you're more familiar with JavaScript, it might be the way to go.
Okay. I just didn't see it in the create menu. That's why I was curious about it.
Yeah, actually, I'm not sure. You would have to look up a tutorial with using Unity script.
Yeah. Okay. Yeah.
But, yeah.
Okay. Yeah. Never mind. It's all good. Okay. Thanks.
Yeah, no problem. They're both object-oriented languages, so you might find that C# is just
It's
as
similar
easy
to it's really similar to Java, so it's all good.
So let's take a look at our player again. So I added the player component, and right now you can see it's just empty. It's just player, right? So we want to actually edit some logic into this player script. So I'm going to open that up. You can open up a script in a few different ways. You can double-click it right here in the project view. You can go over to here, and this is a really convenient way I find to do it. If you can actually double-click on this grayed out area, and it'll pop up. It'll pop up that script in your script editor, your programming language editor, which might be like Visual Studio or whatever you prefer to use. I would highly recommend if you guys are like, oh, I don't really know which one I want to use, what's the best interface to use for coding for Unity, I would highly recommend Visual Studio Code. It's super lightweight, and it is really easy to learn when you're starting out, I would say. It's just a really clean interface. So that's what I have set up.
Yeah. Good call.
Yeah, and you can use it for almost any language too. So it's really nice that if you just want to learn one program and learn it well, then I, again, would recommend. Yeah, so when we open up our player script here, this is Visual Studio Code that I'm in right now. And actually, I will just post a link in chat for installing Visual Studio Code with Unity. There are some specific steps you need to do to integrate it, as with any coding tool with Unity.
Yeah, mine automatically showed up as a pop-up asking me to download the C# extension.
Yeah, exactly. Yeah, Visual Studio Code is really nice for that. And yeah, you do want to install that extension. That'll be useful. Okay, let me throw this in the chat for everyone. So that link there is an official Microsoft made by VS Code. It's specifically a Visual Studio Code tutorial for Unity. So there's a couple things you have to set up to make sure you get all the awesome features that you want. So, okay, we don't really care about programming formatting right now. Let's look at what we have in the script so far. Let's just look at what are we looking at here? So we have two things here. Well, two main things beyond the, if you're familiar with programming language, we have some imports, which you can just ignore. Unity will give you the imports you need for most programs just by default. And we have a class here. Our class is called player. And a mono behavior just means it's going to be a component. So component being the things that you put on GameObjects, in case anyone has forgotten, in case I haven't said the word component enough so far. All right, so when we create a new script, by default, Unity creates two functions for us, start and update. And these are pretty much what you would expect. They even give you some comments telling you what they do. Start is basically when the game starts, or once your object is created in the scene. In other words, like when the game starts, if you just have an object sitting in your scene, this will run. So, you know, let's say I press play. Actually, I'll just demonstrate this right now. I'm going to send a debug message to the console in Unity. So to do that, we say debug.log, and I'll say hello from player. So now we have that, and that's just sitting in our start function. So I haven't done anything other than add a debug line. And I said at the start that when you're trying to figure out what your code is doing behind the scenes, it's a good idea to debug it and check what happens in the console when you run it. So now we have this script. In start, we have a debug line. Let's go see what happens in Unity. Wait for it to update. Press play. And if we go to our console, hello from player. We have one message that happened when we started the game that says hello from player. So that's a good sign because it means our component is already working just from throwing it on the player game object. So let's go back here and let's look at how we can do some more interesting things with this script. And I am just going to restart this because it hasn't. This is why I recommend watching the or reading the installing Visual Studio Code, because there's some steps you have to do to actually make it work when you make a new project. So I am just going to quickly do that. Here, this can be another mini tutorial like the paint one. If you open up your Visual Studio Code, and this happens in Visual Studio as well, not just Visual Studio Code. If you open it up and you find that it's not giving you any auto suggest or any auto completion for any of your code when you're typing, it probably means that your project auto-generated project files when you created your project didn't have like the right formatting for Unity, and it's getting all upset with you basically. And the way to fix that is just go to your project folder and just delete these bad boys. When you go back to Unity, it'll automatically rebuild them, and hopefully with the correct.
Okay. So sorry. So deleting those gets rid of what?
Deleting those will just make Unity refresh your Visual Studio Code and CS project parameters.
Okay.
And
right.
yeah,
Yep.
that'll just, you know, it's one of those little workarounds where it's like, this is just what you do, and then it works. You know what I mean? So
yeah, fair enough.
Just a handy little tip. So yeah,
Okay.
we'll go back in here.
Cool.
And if we open this back up here, wait, we want this to. Wait, I might just have to close and restart this. You only have to do this one time when you make a new project, by the way. Also, not everyone I know experiences this. I think it might just be a bug with some particular systems, but in any case, if you have that bug, that's what you have to do. So you can see it's regenerated these two things. So if we go back here, and this time we can just double click here and it'll open up our script for us. And give it some time to think. Great. the way I check to see if the formatting has been fixed in the project settings is if these two things gray out. Because when all the formatting is working correctly, it'll tell you useful things about your code. Like, for example, the fact that we aren't using these two imports yet, so they got grayed out. The first time I opened this, they weren't grayed out because the formatting was messed up on our CS project, these two files here. So that's just a little tip. That's not part of the coding tutorial. That's just, if you have that bug, that's how you fix it. So now let's look at user input. We're finally getting user input. I know I talk a lot, and I'm sorry about that, but we're there now.
We like your talking.
All right. First thing we want to do. Well, I mean, let's just discuss, what do we want the player to do? And I think probably just moving side to side would make the most sense. That's probably the simplest thing we can do. So, because we have our platform and the player just kind of drops onto it. Let's make the player move side to side. So there's a couple things we're going to want to do. We're going to want the player, we're going to want this script to take the user's input from the either left and right arrow keys or the A and D keys for movement side to side. And we are going to want to translate that to a change in the position of the player. And there's a lot of ways to do that. You can do it by pushing the object via physics. You can do it by directly changing the transform of the object. And you know, there's a bunch of different ways you can code this. And I'm just going to do this pretty much the simplest way I would say you can do it, which is just directly modifying the transform of the object. In other words, in code, doing the same thing I do when I drag this slider in the UI. We're just going to change this value in code. So to do that, Unity, of course, has a fancy little function that gives us the keyboard input from those two keys that we were talking about directly. And to do that, we use their input class. So we can say input dot get axis. And get axis basically means either vertical or horizontal. And that'll automatically convert key presses from either of those two directions. So for example, WASD, W and S keys on the keyboard would give you your vertical, A and D would give you your horizontal movement. And it gives us those values as like a 0 or a 1. Are they being pressed or are they not being pressed? And so that is a really, really convenient way to get player input in one line. So we want horizontal movement in this case. So when you say get axis, it's going to ask you for the name of the axis you want. And in quotes, you're just going to put horizontal or vertical. In this case, we want horizontal. So this will give us the value 0 to 1. Well, I should say specify. It'll give you a value between 0 to 1, but we pretty much just care if it's 0 or 1. Unity does this fancy little thing where when you press the key, it'll really quickly go from 0 to 1 so that when you start moving, it smooths out the movement. Unity's just fancy like that. You just don't have to worry about that. Basically, it's 0 or 1. So we're going to save this in a float variable called, let's call this our X input to deal with the input on the X axis. So now that we have that, we have a variable that is either going to be 0 or 1, or actually it can be -1 too if they press the A key and they move backwards. This is going to give us basically the direction of the player input. So that's cool. Sorry.
Sorry. Why is it a float and not an integer?
So yeah, that's what I was saying
Boolean.
before.
Sorry, I missed that part.
Yeah, sorry. That's why I said why it's like a little detail it's a bit confusing. Unity does this fancy little thing where if you press a movement key, it will, when within the first like few milliseconds that you press it, it'll actually very quickly change the value from 0 to 1. So it'll go like 0, 0.2, 0.4, 0.6 up to 1.
So it's smooth.
Exactly, for movement.
Okay, I got you.
Yeah,
Okay,
Unity's already covering your back with nice smooth movement.
Nice. Okay.
Yeah.
Hey, sorry to
Thanks.
interrupt, Jaden.
Yes.
Is there a difference between input.getAxis and input.getKey?
Yeah, so input.getAxis is going to return to you a value between -1 and 1. Input.getKey, we can actually, this is a nice way to look at the nice auto correct here. I use this all the time, or auto suggest. I use this all the time when I'm coding in Unity to find cool and useful functions. You can also look through their documentation, but this is a really quick way to do it. If you just type input and then dot, it'll tell you all the possible things you could be putting after that dot. And so if we scroll through here, we can see all the possible things we could be getting from input. So, we could see get button, get axis, get joystick names, get key, all this stuff. And Logan just asked, what's the difference between get key and get axis? So get key is a bit different. Another thing I use, if you create parentheses afterward, it'll tell you all the things that can go in those parentheses. So Unity really, it tells you everything you could possibly be doing. Like, you can just look through, these are all the possible things I could put between those parameters. Get key either takes a string or a key, and it'll return to you true or false. This will actually return a Boolean, true or false, if that specific key is being pressed or not.
Which extensions of Unity do you have in VS Code? Because I think that's where you're getting all of the methods from, no?
Exactly, yeah. When you open this up, you're going to want the C# extension right here. So if you go to in VS Code to your extensions window.
Yeah, but you got the C# one, but there's no Unity extension that you have? Well, you have the debugger for Unity.
Yeah, that's a separate thing if you're trying to do some more advanced
okay.
debugging.
I'm just wondering where the methods are, because when I put in the input class,
Yes.
I don't get those methods showing up. So.
Right, nothing pops up. Are these two lines on your screen dark green or light green? These top two.
Those are the same color as the Unity engine. I have a different color setting on VS
sure,
Code.
but they're the same color. They're all the same color.
Yeah.
That's right. So that's what I would. Did you catch my thing earlier about that workaround?
Okay. That's why I delete that stuff. Okay, now
Yes.
I'm gonna delete that stuff. Thanks.
Yeah. So now delete that stuff. Close your Unity project. Reopen it. Give it a few seconds, and then open your script, and then give it a few seconds and see if these change color. If not,
Okay.
yeah. If not, maybe you could try restarting your computer, because sometimes first install of Unity could also have a problem as well.
Okay. Yeah. Thanks a lot. I'll do that.
Yeah. Okay, so just to finish up, get axis versus get key. I would say in the simplest terms, get axis is a number. So it returns a number that you can use for smooth input. And it also gives you from two keys at once. So in this case, it's giving you the left key and the right key at once. Whereas get key, you actually enter a very specific key. So in our case, we could enter a key code. We could say keycode.a, and that would give us the A key. So if we wanted to directly check left input, we could say check what happens if they press the A key. And I have used this in several games, because sometimes you don't just want to grab an integer value from the input. Sometimes you want to say, like, if input.getKey do some very specific stuff with that particular key. For example, if you wanted W to be a jump button, but you didn't want S to do anything, you'd probably want to say get key code W and then do stuff. So yeah, that's a good question. But for now, let's just take this input between -1 and 1, and let's use that to change our transform of our player. Remember, the transform is just the position, the rotation, and the scale in the world. So it's pretty easy to get the transform. You just say transform. That gave us the transform component. So this is the transform component. And you can see if you hover over it, it says the transform attached to this game object. And the reason we can just say this is because every game object has a transform. So we specifically want to change the X position of the transform. So we want to say transform.position, and we want to change this value to something different. So one specific thing that I'll mention is that a position is a vector. So it has an X, Y, and Z component. In this case, we only care about the X component. But when you're talking about math and how Unity does math for vectors, you can't just directly set the X property of a vector. You have to give it a vector. You have to give it an X, Y, and Z for it to actually understand. So like if I tried to say, for example, transform.position.x equals 5, it's not a fan of that. And that's because X is going to be read only. So we can't just directly set a subcomponent of a vector like this. I know it's getting a bit specific, but I just want to explain why we can't just say .position.x equals 5 or equals X input, for example. We actually have to say equals new vector 3 in this case, because we have 3 dimensions. Actually, we could even go so far as to say vector 2, but just for the sake of this, I'll use vector 3. The reason you can use vector 2 is because it'll automatically cast it to a vector 3 for you. But that's programming details. So we'll make a vector 3. And so what we want this to do, let's just go over what we want this code to do. I'm actually going to add a comment here. Get user input, and we'll say -1 to 1. And then here, we want to change the position on the x-axis by an amount, or we'll just say it based on the user input. So mathematically, what we're saying is take the current position. In our case, the object is at 0, right? Position equals 0 on the x. And we want to add to that or remove that. So in our case, we'll just say x input. We'll just say, actually, in this case, we want to add to it. So we don't want to set it to 1 or -1. We want to add the input that we get from the key. And we don't want to move it in either the Y or the Z direction. So is there any questions about what these 2 lines of code are doing? This is getting the user input, and this is changing the transform position of the player object by an amount based on the user input we got. So if this is -1, then that'll be moving backwards. If it's positive, it'll be going forwards. All right, see you, Logan. Yeah, thanks for dropping by. Hey, Jonathan. Welcome. So yeah, so any questions about these 2 lines of code? Is that making sense to everyone? And I guess one thing I should point out, because people might not be familiar with it, this code is going to run every frame. So because we put it in update, Unity is automatically going to call this function every frame. So you might have when we talk about every frame, a game has like a frame rate. So every interval, every certain amount of milliseconds, Unity is going to refresh everything in the scene. And when it does that, it's going to call the update function of every script in the scene. So when it calls our update function, what it's going to do is it's going to check, does the player currently have either their A or their D keys down, or their left or the right arrow keys. It's going to check that. It's going to get the -1 or 1 if they are, and then it's going to update the position of the player based on that amount. And there's actually a problem with this code because we have it in update. Now, I said this is running every frame, and typically you can see frame rates, that is the number of frames per second, up to 60. So this might be running 60 times per second. Let's say we held the right arrow for all 60 of those frames. That means the player position would move by 60 in 1 second. Now, if we go back to Unity, let's just get a bit of scale of what moving this thing by 60 would look like. I'm going to zoom out. So here's our object. I'm going to move this thing by 60. That's where 60 is going to put us in 1 second of holding down the right arrow key. And that's not really what we're looking for. That's really fast. It's going to go from here to there in 1 second of holding down the key. And that's because it's running every frame. That's assuming we have 60 frames per second. So that's not exactly what we want. But Unity has a really easy way for us to scale by the amount of frames per second. So we don't want it to move 60 units per second. We want it to just move 1 unit per second. But we still want it to check for the user input every frame, because we don't want the user to have to hold their arrow key for 1 second, and then every second we just check, oh, are they holding it, and then add 1. We want to check it every frame, but make sure that it adds up to 1 over the course of 1 second of holding it down. Hopefully that is understandable what I'm saying.
I'm catching what you're throwing.
Perfect. Awesome. Okay, so the way we do that, so we have this value over 60 frames. This is going to be 60 because if the user holds down right, because it's going to be 1. We want to scale this so that it's multiplied by 1 over 60, or in other words, it's divided by 60. And Unity has a really nice thing called time.delta time. You're going to see this a lot if you're doing things like this based on input or based on doing things in update. Time.delta time gives you the time in seconds since the last frame. So if you have 60 frames in 1 second, this is going to give you how much time each of those frames were, which is going to be, each frame is going to be 1 over 60 seconds. And 1 over 60 is the exact value we needed, right? We want to multiply this by 1 over 60. So that's really convenient. It basically allows you to scale something that would be happening every frame to be something that happens every second. And so that's kind of a nice magic number. Hopefully I explained it well enough as to why we use it and how that's working. If there's any questions, please put them in chat, but that's why we use time.delta time. It's basically going to scale our input to be, instead of every frame, it's going to scale it so that when I when I add the position with the X input, instead of being 1 every frame, it's going to be 1 every second over the course of 60 frames. So that was a lot of, explanation for something that was pretty simple. And, I tend to do that. So apologies if that was too much for people. But in the end, get user input, add it to the X. So now that we have that code, let's go ahead and run this and see what happens. All right, I'm going to press the D key. And look at that. That's just beautiful. And I'm going to press the A key. I'm going to press the right arrow key. I'm going to press the left arrow key. So Unity's already detected all these inputs for us, and it's already dealing with this really nicely. So that's pretty awesome. So now we actually have a moving player in our scene, and there's physics. So I mean, we're already getting pretty far with just a few changes to the scene. But what if we want the player to go faster? He's kind of, he's kind of snailing along right now. It's about the speed you might see a snail moving. We want him to move a bit faster because that's not going to be very fun. And to do that, we're going to add a variable that you can modify. So I'm going to make a variable called speed. This is going to be a public float speed. And I'm not going to define a value for that in the code, because the way Unity works is when you have a class like this, when you make a script, and you make it a mono behavior. In other words, when you make a component like this, because the script is a component, any public variables are going to appear in the Unity interface. And that is how you're going to enter the values for those variables. So if I go back to Unity now that I've saved my script with this new line, we're actually going to see a new field here that says speed. So right now the speed is 0 by default. And if we make it 1, then we're going to be multiplying, well, we aren't multiplying yet, but we're going to be multiplying it by 1. So for now, I'm going to say, let's move 3 times faster than before. So now let's go back to our script. And this is going to take whatever value we just put into the interface there. So now what I want to do is multiply this input by the speed. And believe it or not, you can actually just multiply it. It might be surprising, but yeah, that's it. So now we've added speed. So basically, this is going to be 1 times the amount of speed, and then it's going to be scaled so that it's just per second. So now let's see if our player is moving at a different speed. If it's not, something's gone horribly wrong. There we go. So now we have a nice moving player. And that's pretty much going to cover the movement aspect of this. Is there any questions about movement and user inputs, or was that pretty clear?
No, sorry. Can you go back to the code for a sec?
Sure.
So where did you initialize the speed, or you didn't?
Yeah, so I didn't. So speed, because I made it a public variable, Unity automatically takes that and makes it into, puts it into a property on the interface.
Okay. Yeah, sorry. I remember you saying that. I just
Right.
Yeah. Okay.
Yeah, it's all
cool.
good. No, good question.
Cool.
This is something that people get confused about a lot. Is they'll go in, they're used to normal programming, they'll enter 3 here. Or let's say I enter 3, or let's say I want it to be 2.
Yeah.
So this is 2 here, but in Unity, I've set it to 3, and it's always going to take this value. It doesn't care what you default it to. It's going to take what you put in the interface.
Okay, so it automatically overwrites stuff.
Oh yeah.
Okay.
As soon as it's a public variable, this is the top priority right here, is the interface.
Okay, so there's some method overloading there.
Yeah. Sorry, go ahead.
Yeah, and then the only other question is the vector 3. So the vector 3 is so the first one's taking changing the position every frame, and then what are the second and third values there again?
Oh yeah, so you just mean in this part here, what are these 2 zeros?
Yeah.
So yeah, the reason we have 2 zeros here is because this is a vector with an X, Y, and Z component, and we only want it to move on the X.
Okay, gotcha.
Yeah, so we just set
X,
the
Y,
Y
and
and
Z.
Z to 0.
Okay, and there's no vector 2.
There is a vector 2.
Oh, okay. We're just using, okay.
We're just using vector 3 just because.
That's interesting.
Yeah, we can use a vector 2. So when I first did this, I said we could use a vector 3 or a vector 2. And the vector 2 will just automatically be casted to a vector 3 with the Z set to 0.
Yeah. I apologize if I'm not picking up everything because I'm coding along while you're talking, so I'm trying to get
that's
most
good.
of it.
I totally get it.
Yeah.
And it's good that you're asking questions too, because it also means other people can get refreshed on.
Yeah, they're probably benefiting from it too.
Yeah.
Cool. Yeah, awesome. Thanks.
Yeah, no problem. Okay, so we have a lot of exciting stuff happening here with user input and movement. So let's move on to the next interesting thing we can do. And yeah, that the code and stuff and process we just went through, it would be the same thing for making the player jump. You might get input from the W key, and you might increase the transform, or you might use a physics component. If you have any questions about how to do that kind of stuff, you can ask them at the end, and we can go over those. But the concept is very similar to what we just did with side-to-side movement. So the next big thing that I want to talk about in this introductory session here is prefabs. So we've talked about game objects, which are objects in our scene, and everything in our scene is a game object. But what happens if we want to add something into our scene after the game has already started? So after we press play, what if I want to click on the screen and I want a new cube to pop up? Well, we could have a cube in the scene. We could make it invisible, so we could turn off its sprite renderer, and then when the game starts, or when we could get a click input, and then we could make it visible again. But that wouldn't really be too useful. That would be kind of, it doesn't solve the larger problem of how do we create a new object. And that's where prefabs come in. So a prefab is a prefabricated object. And basically what it means is you can take any object in your scene and save it to file. So let's take, how about this? Let's make a cube object. It's going to be like our player, but it's just a cube. It doesn't have any movement logic. I'm going to reset the transform position. And again, I'm going to give it the same square. I'm going to make it red this time. Differentiate it. And I'm going to, again, give it a rigid body 2D for physics. I'm going to make it dynamic so it moves around. And I'm going to give it a collider as well, box collider 2D. And I'm going to keep that all default. So now we have this cube, and if we start the scene, zoom is getting in the way of the start button. Okay. Now we have these stacked cubes. So this is basically just another cube with physics and colliders. So that's great. But now we want to spawn that cube, instances of that cube, over and over again every time we click. That would be pretty cool. So the way we're going to do that is we want to save this cube to file, and then in our code, we can just reference that file and spawn a new version of the cube from the properties in that file. And so prefabricated just means it's like an object with all the same properties. So we define all the properties here, we save these properties, and then we can spawn them, spawn more of these exact same objects using those properties. And so because it's an asset, because it's a file that we're saving, we're going to go make a new folder called prefabs. And we can actually just drag our cube directly in there. And Unity will make all the prefab and all of its saved stuff for us by default here. You can see the cube in the scene turned blue because now this is a prefab. This is just one instance of our blueprint, which is our prefab here. The prefab isn't an object in the scene. It's just a set of all the data that you need to create our object. So hopefully that's not, is that good for everyone? Is that making sense? So I'm actually going to remove this instance of cube out of the scene because we've already saved all of its data to file here in the prefabs. So now what we want to do is what I want to do is I want to click on the screen and I want to create a new cube. Let's just say you click anywhere and it'll just drop from the sky right above the player. That's pretty simple. So let's actually do this in the player. We're going to go right into the player script again. And let's get some more user input. So this is going to be let's get horizontal user input, because now we're going to be getting mouse input. Get left click input. So again, we can look at our input class here and see what would be useful. And I have a feeling mouse is going to be useful. So get mouse button. By the way, none of this talk is pre-planned other than a couple bullet points. I'm just going for it. You can see just pressing dot is a great way to just remind you of what functions you need to do certain tasks. I just typed input.mouse and then I found get mouse button. So now I can remember, oh yeah, mouse button. That's how I get the things I want. So the way Unity does mouse buttons and inputs, so previously we typed horizontal when we wanted to get the left and right movement keys. In this case, we want to get a left click, and Unity uses kind of a gaming slang for what you might call left click. They call it fire one, and fire one is it's your primary fire button. So Unity is it's coming from kind of assuming you're making a 3D shooting game. Fire one, it's your primary fire button, and that'll give us the left click. And actually, just quickly for reference, you can actually see where all of if you forget these names, you can look them up. But you can also see and change all of these names for different inputs. If you go to project settings under the input manager, sorry, not that one. There's two input managers now because Unity is confusing like that. Under, where'd they put it? Oh, they moved it. The most recent Unity update, they moved it. Okay, wait, I will go try and find it. Wait, where did they move it? Maybe I won't show you guys. Project settings. Yeah, I don't know where they moved that. I could look it up, but the point is, you can also look it up. There's input settings for what all the inputs are named and what keys they map to, and you can go there and see what all of those default values are. So I just remembered that it was Fire1, but there's actually, oh, never mind, it is this one. I'm just dumb. Never mind, it is this one. In the project settings, you go to Input Manager. You drop down the menu that says axes, and you can see what they all are. So we used horizontal before. There's also Fire1 defined. So we can, this is separate. This is just like if you want more information about why we use those names, this is where it's stored. So you can change what name it uses. You can change what keys it uses, what alternate keys it uses, all that kind of, all those crazy values. We don't really need this, but just for background, I like to give background on why we do everything. So yeah, so we're going to get Fire1, which is defined in that menu I mentioned earlier. And this is going to return to us a Boolean. So Boolean, let's say Boolean is mouse down. It's going to be equal to that value. In button. Oh, they changed this to my input. Oh wait, no, sorry, it's get button. That's why. I'm getting confused with my terminology. All right, ignore that mishap. Mouse button is a different thing than button. It's just one of the many, interesting things you'll learn about Unity. Button is all those words that I showed in the interface. Mouse button is integers that are specifically mapped to certain things on the mouse. I think you can use either one, but for now we're just gonna use get button Fire1. Okay, so this will tell us if the mouse is down on the current frame. So we're gonna say if is mouse down. We want to then spawn a cube. So we don't have a reference to that cube. Yeah, the input setting is under Input Manager, Axis. Yes, yeah, exactly. Which we discovered after a little bit of looking around. Okay, so if is mouse down, we want to spawn a cube because that would be fun. But we don't have a cube anywhere. So let's look at how we can do that. And the way we can do that is by making a new public thing. This time we're going to actually look for a game object. So we want a reference to a game object that we're going to spawn. So we will call this cube prefab. And now that we've saved that, we can go back here and we can see, once this loads, that we now have a cube prefab field. And this is looking for a game object. Now, specifically, we want a prefab that we can use to get all the properties from and spawn that as a game object. So I'm going to drag my cube prefab that I made earlier into this slot. If I had just dragged a cube object from the scene into this spot, it wouldn't know. So it depends on the circumstances, basically. If you drag the cube from the scene into this slot, it would have an instance of a game object. It wouldn't have a prefab which has all the data stored on it, basically. And if that cube in the scene got changed at all, it wouldn't be able to reference this anymore. So that's basically why we have to use prefabs, which are the things kind of chunking all that data together instead of actually being an instance in the scene, active instance in the scene of a game object, if that makes sense. So yeah, so we drag the cube prefab into there. And that means this will now be referencing the cube prefab. The way we spawn objects is using instantiate. which basically means we're going to create a new instance of it and put it somewhere in the scene. So we want to instantiate the cube prefab. That is the object we want. And we want to put it, so if you can see here, there's a bunch of possible parameters I could use here for this, this instantiate function. We're just going to use this first one. We're going to give it the object we want to spawn. We're going to tell it where we want it to go and what the rotation of the object is going to be. We won't really care about rotation. We're just going to leave that as default. But we do want to tell it where to put it. So I'm going to tell it to spawn a cube at a new vector 3. And let's spawn it at 0 on the X, so in the middle of our screen on the horizontal view. And we'll spawn up in the air, so at 5 and then 0 on the Z. So this is X, Y, Z, 0, 5, 0. And that's the position in the scene where it's going to spawn. And then we need so quaternions are how Unity represents rotations. In our case, we don't want it to be rotated at all. So we can use what's called quaternion.identity, which is just no rotation. So now we have this awesome line, spawn this prefab at this position with this rotation. And we're only going to do that if we detect that the mouse is down on this frame. So let's check that out. Oh, Zoom is getting in my, okay, there we go. All right, I'm going to click the mouse. We're going to see what happens. Oh my goodness. That was a lot of blocks. I clicked for a very brief amount of time. And the reason for that is because we're checking for that mouse input every second. So it detected about 30 to 40 key presses during that 1 second because it checks every frame. And it spawned a cube for every single one of those. So we now have a bunch of cubes in our scene, and we can push them around actually with our player a little bit, but we're kind of stuck in here. But yeah, and if I hold this down, it's going to spawn a whole bunch of cubes. So that's a blast. Spawning stuff is really fun. Yeah, that is a lot of cubes. Yeah, I know, right? And we can even go further, and that's really fun. Should you add a locking mechanism? Yeah, what I typically do when we're looking at spawning is I have a cooldown. So you could say like, I make a separate variable, and I just every time you click, you set it to 0, and then every frame. Well, I mean, I could just actually write the code for this to make it so this doesn't happen, right? Let's do that actually, because that's kind of fun. So I'm gonna make, yeah. So basically, like Gustavo said, can you add a locking mechanism? So basically, what that means is, if I'm understanding him correctly, and this is how I normally do it, is you want to spawn one and then lock it from spawning any more of them until a certain amount of time has passed. So, or you could just say until you let go of the mouse. You could wait for them to release the mouse button. Actually, they might already have a function for this. Do they have a get button down? Yeah, actually they do. So we don't even have to do this. You can just use get button down, which is a nice handy function I just reminded myself existed, which does this for us, which is it only returns true during the first frame you press the button, the mouse button down, or whatever button it might be. And it won't return true again until you release the mouse. In other words, this is only ever going to happen once per click. So by using get button down instead of get button, that's that change. It is really helpful. Yeah, Unity has functions for almost anything. I was going to add a little timer to it so that it did it every 0.5 seconds. It spawned a new one. But if you just want to do one per click, this is a really easy way to do it. If you do want to have it so you can actually hold the mouse down and it spawns one every few seconds, you still need to use get button, and then you can just implement a little timer. But we don't even need to do that. This will be a good way to demonstrate it. Okay, I'm going to stop the old playthrough here. I'm going to restart it. And if I hold down the button, yeah, we can see only one spawns. So now we've got and every time I click, another one spawns. So now we've got a nice infinite source of cubes and fun in our scene here. So that's pretty much it for the fundamentals. I will open this up 1 second of where to go from here, because that's pretty much the end of my introductory tutorial. And we're going to have questions at the end if there's any more concepts or things you guys want me to cover for, like we still have more time. So if you guys have concepts or anything you want me to cover, then let me know in the chat. I'm going to open up this slide here. You know, I'm not even going to bother formatting that. Here we go. There's that. I'm not even going to maximize it. So where to go from here? Online tutorials. Unity is a great engine because there's so many tutorials and there's so much documentation about it. In particular, one that I would recommend you check out is Brackeys. Brackeys has not only a bunch of full walkthroughs of how to make certain types of games or making an introductory game. He also has a bunch of videos on very specific aspects of Unity, like shaders or specific scripting things. Like there's a bunch of different things. He almost always will have a video on it. So that's a great reference to check. It's a YouTube channel called Brackeys. That's an awesome way to do it. I would also recommend looking at the Unity Learn references. That's where I started out. And I would just recommend going there. They have a bunch of full game tutorials where you just make a game start to finish. It probably takes 3 hours, 4 hours if you're a beginner. And this tutorial we just had there, you'll see a lot of those concepts coming back in those kind of tutorials. That kind of walkthrough is a great first project. The other thing you can do is join our Discord server, which I'll link again for anyone who wasn't here earlier, because we often run not only events like this, which are introductory for you, we also run challenges every week, which have beginner and advanced components for things like creating a player. For example, the one this week is create a player with movement. So it's just something to get your creative muscles working, get you started on making some basic parts of games. And every week we'll add a new challenge that'll add on to a project for you. And we also have advanced challenges if you're already familiar with Unity. And yeah, and that's also a great way to work with other people, because you can do that in a team, you can do that solo. And we also have a ton of knowledgeable people in the Discord server. So if you ever need help with any kind of Unity or other game development related questions, you can go to our help channel, send a message, and anybody will be there as soon as possible to help you out. So that's pretty much the resources that I would recommend for Unity if you're starting out. So do we have any specific questions about things? I think Jonathan mentioned trigger. Is that for, you want to go over triggers?
Yeah, I thought that may be pretty useful. It's
Sure. Yeah, that's a good one. So triggers is part of physics. Anyone who doesn't know, a trigger is basically, Zoom's getting in my way again. There we go. A trigger is basically, let's say you're moving through a scene. Let's say I'm moving along, and I want something to happen when the player reaches the end of this thing. Let's say I want an event to trigger, right? And the way we often do that in games, you could do it, but you could manually check every frame the position of the player. You could say, oh, is the player's position at this? Let's say you want it to happen when the player passed this line. Let's say x equals 7. You could check every frame. Is the player's x greater than 7? Is it greater than 7? Is it greater than 7? Or you can use something called a physics trigger. And the way that would work is you'd put an object right where you want the trigger to happen. So you might add an invisible game object, for example, or it might be a visible game object. It might be a doorway, for example. In our case, we can just add a invisible game object here. I'll make another empty one. We'll call this our trigger example. And what we'll do instead of checking that every frame is we'll have an invisible trigger that when the player collides with it, with Unity's physics engine, it'll trigger an event. It'll make something happen. So just to make this simple, so our trigger, it needs to interact with the physics engine of Unity. So anything that interacts with physics needs to have a rigid body. But in our case, it can just be static. It's just going to be sitting here. So I'm going to put this at y equals 7, or x equals 7 rather. Let's just fix that. So I'm going to put this right there. And a nice little trick that you'll often see in games for invisible triggers like this, you just want to make them really tall. So you really want, so I guess here, let me add a sprite so you can actually see what that size just did. Let me add a sprite render real quick. I'll remove this after, but. So I just made it really tall. Like you can make this like 50, 100, whatever. And this is just going to be an invisible trigger that whenever the player passes through this point and collides with this thing, then we want something to happen. So in our case, I'll just print something to the console. So I'm going to remove this because we want it to be invisible. So we'll just keep the physics. We won't have the sprite on there. I'm going to add a box collider 2D. And you can see the outline of the box collider 2D is nicely illustrated for us. And here we're actually going to look at one of these properties that we ignored earlier, which is trigger. And this basically means it's all the physics is going to count as normal, but instead of actually having collisions, it's still going to detect when collisions happen, but it's not actually going to physically block collisions anymore. So our platform below here blocks collisions whenever something like the player tries to collide against it. This will detect when those collisions happen, so we can use it in code, but it won't actually prevent the player from going through. So as far as the player knows, this isn't even going to exist in our scene. They won't even see it. And so that's why it's really nice, a nice way to deal with events in a scene like this. And this is also great for 3D too, because imagine how much harder it would be to say like, oh, if the player's at greater than X position, but it's in 3D now, it's just way more work than you need. It's way easier to just have a little box that when the player enters that invisible box, then the thing happens. So trigger is just a great way to do events in any kind of game. So I'm going to make this a trigger. And then we are going to go into the player, and we are going to use a nice little function called onTriggerEnter. And this is another function that's provided by Unity, just like update or start. And it's called onTriggerEnter, in our case, 2D. So this is going to get called anytime the Unity physics engine detects that you're colliding with another rigid body, or another collider, that is. And specifically, ones that are set to triggers. This won't happen when you step on the platform. So, and to be clear, this is going to get called anytime the player enters any trigger in the scene. So the other way we could do this is to make a new script on our trigger object and check for the player to collide with it, and then do something specific to that one trigger. So we'd actually make a new script on this object and check for the same way that we're doing it here, but just on this object. If anything collides with that, then it'll trigger the event. And I mean, in a real game, that's how you'd want to do it. But in our case, just to use one script, we'll just say anytime the player enters a trigger, we're going to enter something in chat. And trigger, you actually need to say collider 2D call. You can call it whatever, but that just what this is saying is anytime we collide with something, anytime we collide with the trigger, get the collider that we collided with so you can do stuff with it. We're not going to do anything with it. We're just going to print out. Ouch. What would you say is good practice when creating different scripts? You mean as to when you want to create different scripts? Like when you want to create new scripts? Generally speaking, I'm generally of the mind that this is a pretty subjective question, but generally speaking, I'm of the mind that when you're creating new scripts, when you're creating new logic, you want to have all of that logic be contained within the object that you're putting it on. So, I mean, what I'm doing here is against that practice that I said. That's why I mentioned earlier, you probably want to actually have it on the other object. But when you create a new script, so let's take this for example. We're adding a trigger, and we want that trigger specifically to handle some logic for when the player collides with it. And so in that case, if we want something to happen when anything collides with this thing, generally speaking, I would say the logic should go onto the trigger. And the same thing applies for, say, user interfaces or enemy objects, anything like that. Generally speaking, I would say the logic for what you're doing should be on the object that is doing that thing. Like, you want to keep everything, you don't want the player to be doing everything, for example. You want to keep each object doing the things that it's supposed to be doing. So I mean, I guess just for the sake of following my own words, I'll add a new script. And this would be a good way to show you can add a new script here. Yeah, and like Jonathan says, creating different scripts allow for more control when you want to reuse those scripts on other game objects. Yeah, that's true too. Like, let's say you had an enemy script that has some like trigger on it that says, like, when it collides with the player, do some damage or something like that. You could have that script on the player and check for that specific object. If the player collides with this specific object, then do this, then damage the player. Or you could have an enemy script, and you could put that on each enemy, and it doesn't have to be the same kind of enemy. And so that you wouldn't have to be manually checking if you hit the right object. You could just put this script on each enemy that you want the player to collide with and take damage from. And you only ever have to write one script, and you never have to do more than one check other than saying, did I hit the player? Instead of having to go into the player and write a script that checks for every single possible enemy that the player could collide with. So yeah, that's a great point, Jonathan, that, if you create a script that's, compartmentalized for that object specifically, then it gives a lot more control for reuse as well. Okay, so on our example here, I'm going to add a new script, and I'm going to call it trigger example again. This is going to be a script called trigger example. So you can create a script directly from the add component menu here. And when you do that, it'll just put it into your base project folder. So I'm just going to drag that into the scripts folder and go back to trigger example. I'm going to open that up. So again, we've created a default script here, but I don't really care about all this stuff. I don't really care what happens when the trigger spawns into the scene. I don't really care what happens when every frame. I just want to know what happens when this thing collides with the player. So this is going to be on collision enter 2D, I believe. So this is going to say when the collider of the player. So this is kind of an interesting distinction. Here we were saying when we entered a trigger. So on trigger enter, because the player was entering the trigger. In this case, the trigger is going to say on collision enter. So when the player's collider, which is not set as a trigger, enters this. I might have that backwards too. It might be checking what you are, but I think this is the right way. And this is going to check for a collision. So this is going to, when Unity calls this function, it's going to pass it some parameters that gives you a bunch of information from the physics engine itself about what exactly just happened in that collision. And that's useful if you want to do some physics stuff in here, or check like the angle that you hit something. In our case, we just want to know, did it hit or not? And we're just going to say debug.log. Got him. As in, we got the player. And I'm going to remove this from the player because we're doing it in here now. So this is running. Remember, this is running on the trigger that we made. It's running on this invisible wall object. And it's this script here. And Unity is automatically going to call this anytime the player enters. Anytime the player enters the collider of this trigger. So with all that done, we have our script, we have our player. I'm going to start the scene, and we're going to see if it prints got him in the chat. it didn't, which means I did have it backwards, and this is actually supposed to be on trigger enter. So backwards, the opposite of what I said earlier. If you have a trigger on the object, it means you need to use on trigger enter. If you have a collider on the object that you're writing the code on, you need to have a on collision enter. And the only thing that determines that difference is whether or not you have is trigger checked off in your collider component, which is this checkbox that we did earlier. So I'm going to change this to on trigger enter with a collider. Let me in Zoom. Zoom's got a panel that keeps blocking the play button. There we go. All right, let's see if it prints it this time. There we go. So now when we pass this point, that script got called and printed got him in the chat. So that's when the player entered the collider for our invisible trigger. That's that. By the way, what I just did is I switched back to the scene view while the game is running so that we can actually move around and see what's happening and see values instead of just previewing the actual game. So yeah, we can see we've entered the invisible wall, so it got printed in the chat. So yeah, but beyond the little mix-ups there, it's actually very simple to do a physics trigger like this. It's just one function and then whatever you want to do when that happens. So yeah, Unity makes that really easy. Okay, so hopefully that made sense. Is there any other questions? Any other windows you guys want to know more information about? Any other specific things you want to be able to do in the game that you want to know more about? Any other information like that?
This is awesome.
Thanks, man.
My comment. Yeah, I feel like I got a grasp of it now. Like, I feel like I could probably start working on something just from obviously I'd have to look at the docs and stuff like that, but it's a really good intro. I'm sure there's people with questions though too.
Yeah, thanks. I really appreciate that feedback. Yeah, does anyone have any questions about what I talked about earlier, or any thing you guys want me to talk more about, or something else you want me to introduce?
What's quaternion mean again? Quaternion is a class, of course, but what does it do again? Quaternion identity? I just forget what that does.
Yeah, quaternions are actually a pretty complex mathematical construct, but in simple terms, a quaternion defines a rotation in a scene.
Right.
And so quaternion.identity is if you hover it, it says the identity rotation.
Yeah, I don't have it set up for being able to hover still.
Okay,
so.
yeah.
But yeah, I guess I could look at the docs and get that sorted out.
No, that's a good question. No, quaternions, it's good to understand what they are.
Yeah.
Yeah, it just means the default rotation, so we're not rotating it at all.
Yeah. Okay, got you. So if we were to rotate it, then we'd go quaternion identity and then put it in as an angle or something like that, or no?
Yeah, if you wanted to specify a specific rotation, you could do some things. So I mean, it's probably not a good time to get into quaternions specifically.
Okay. Yeah, I guess that's kind of
so
I
basically a quaternion is a 4-dimensional vector that is translated through some complex math. You don't even learn it in university. It's graduate level.
Cool.
And yeah, to be honest, I mean, of course, I don't understand it.
Could you please just do a graduate level linear algebra course right now?
Yeah, so this is you apply the transform on the cross product. No, but they do, that's just I could tell you what functions you can use, but I wouldn't be able to explain to you what exactly they're doing. So things that I've used with quaternions, angle axis.
Yeah, that's kind of more what I'm interested in, the applications. Yeah. We don't have to go through the math.
for sure. So for example, axis angle. The functions, if you press quaternion dot, once you have your thing set up, you'll see a bunch of possible options. But axis angle is a nice one, for example. This allows you to specify an axis and the amount of angles you want to rotate around that axis. And this nicely uses a vector 3. So for example, we might want to rotate around, I'll show another nice little feature you can use that I use a ton, by the way. That's actually a good lead into this. If you type vector3 dot, they've already defined some basic vector 3s for you. So you don't have to say new vector 3, blah, blah, blah. If you just want to say vector3 dot right, that's going to be equal to 100, which is a really common one where we use all the time. In this case, we want to rotate around forward, which is like, I mean, here, wait, I'll just, wait, can I just turn on my camera here? One sec. I'm going to show you guys with my hands what this is looking like, because that's just going to be easier. Start video. Can you see me?
Yeah.
All right, so we have a forward vector. This is like into the screen. And so when we're rotating around that axis, like we're going to be rotating like around that axis like this. So when we say like axis angle, we give it the axis we want to rotate around and then how many degrees around it like that. So in this case, we say the forward direction, which is like into the page or into the screen. And then we're going to rotate a certain amount around that. So like if we said 45 degrees, I think this is in radians. Oh, actually it might be in degrees. Let's just try 45. The F means it's a float. Oh, it's absolute. Oh, okay, angle axis, same thing. Okay, reverse. Same thing, but different function name. Some of the functions, like if you do quaternion dot, some of them are like deprecated functions that they still have that exist that like they still work, but they're deprecated. They're just there so that old programs still work. Oh yeah, I'm doing it all the time here. I'm so used to these old ones. So this is going to rotate 45 degrees around the direction around the axis, which is into the screen. I mean, let's just see if that works. So when we spawn, I guess I can turn off my camera here. Not that it really matters, but I figured it wouldn't really add anything if my face was in this. So, all right, let's restart the scene. And let's try clicking and see if they spawn at an angle. And they do. They spawn 45 degrees. And it's so perfect, in fact, that it didn't even fall.
Wow.
If I drop another one, it probably will. Yeah.
Okay. That's sweet.
All right.
Thanks, man.
Yeah, no problem. And Adam says, got a dip. Yeah, thanks, man. I appreciate that. And Gustavo says, this is to the earlier comment I think you made that said, yes, totally. I always had video game ideas, but never had the time nor teammates to make them. I'm glad you're excited about the club, man. Yeah, we'd love to have you. We're looking for anyone who's interested. You know, a lot of us are just people in the same boat as you who just really love video games, but just never had time. Never knew people who were knew other people who were interested. Yeah, that's kind of what the club's for. You know, it's if you're a programmer, maybe you just don't have artistic experience to make a game. Well, that's perfect because our club is full of people who like art, like programming, like music. So the goal, hopefully, is that you'll be able to find someone who can, you know, fill out those complementary skills that you might not have. Yeah, we got composers too. We've got a lot. We've got composers. We've got people who are interested in voice acting. We've got I think pretty much everyone is interested in game testing, play testing your games. Yeah, I mean, you'll find a lot of really, really talented people in our community. And if you guys have anyone that you think would like to join, then feel free to let them know. You don't have to be a programmer. In fact, we want people from all different backgrounds. Even if like marketing, if you're interested in marketing games, anything like that, it's really open. Okay, well, if there aren't any more, yeah, we need management students too, exactly. Open for everyone, 100%. So yeah, if you guys have no more questions, then we can end it off there, and I will send out the recording to everyone, and I can also, I can throw, if you guys want me to throw this this project, this sample project, into a zip file?
Yeah, that'd
you
be
guys-
cool. We'd
Yeah.
like that, I think.
I can actually just throw this on. I'll throw this on our GitHub, and you guys can download it directly from there if that's interesting to people.
Yeah, that makes sense.
Cool. All right. So any other questions? Or are we good?
Yeah, that was awesome. Like, really, really great job, man. It's
Thank you.
wicked.
I appreciate that.
I learned.
That's good. That's good. Yeah. Thanks, guys. I appreciate it. Oh yeah, I can link the Discord one more time here. If anybody missed it. Oh yeah, you already got it. It's too quick. All right, I'm gonna stop the screen share. Oh wait, no, here we go. I know what I'm doing. Pause share. Oh, stop share. There we go. First time using Zoom, you know, it's a learning experience. Well, first time presenting in Zoom. I'll stop the recording.